Alright, in this video we're going to look at rationalizing the denominator, which is really just dividing with radicals. In our last video, we learned how to simplify, multiply, and add and subtract. Here we're going to do the last of those operations, the one we didn't cover. We're going to divide. Now, we are going to use the ideas of simplifying and multiplying today, so you need to make sure you remember those from the last video, but we're going to add to that and we're going to divide. Okay, before we get started, there are two rules you have to know that you have to remember when you're rationalizing the denominator. And the first one is that you cannot have fractions under the radical sign. Okay, so no fractions under the radical sign. We can't divide under a radical. It doesn't work. And what we're going to look at today is how to get rid of that, how to fix that. The second one is that you cannot have a square root in the denominator. No square root in the denominator. Another way of saying that is that you can't divide by a square root. Okay, so if I say 4 divided by the square root of 3, that's not going to work. You have to fix that. Okay, and we're going to look at, again, we're going to look at how to fix these, and that's our goal today. We need to fix those two rules. We're going to split it up into two types, one for each of the rules, and we're going to actually start with rule 2, no square root in the denominator. Okay, so that's going to be our type 1, square roots in the denominator. Here's our first example. We're going to work it out together. You got 3 over the square root of 2. The reason this doesn't work is because we're dividing by the square root of 2. It's in the denominator, the bottom of the fraction. Our first step is to try to simplify the radical, if we can. If I could spell, that would be nice. Simplify. Okay, try to simplify if we can. Root 2. Root 2 is not going to break down. It's already broken down as far as it can. So we're going to leave it. Step 1's not going to work for us on this problem. So I'm going to rewrite it over here. 3 root 2. Since we've tried that, the next step is going to be to choose what I call a well-chosen 1. Okay, now it's called that because it's going to be some number over itself. Anytime we have a number over itself, it always reduces to 1. Okay, 1 over 1 reduces to 1. 10 over 10, same number over itself, reduces to 10. But we're going to pick a specific one. That's why we talk about well-chosen here. Pick a specific one and multiply by it so that it will get rid of our denominator. Okay, but again, it has to be the same on the top as it is on the bottom. Now, to figure that out, we look at the denominator. Okay, and you want the radical in the denominator, and that's what we're going to use. The radical in the denominator. Okay, in this case, it's the square root of 2. So that's what we're going to multiply by. Square root of 2 over the square root of 2. Now again, it will reduce to 1. We're not going to go ahead and change it to 1, but root 2 over root 2 is really 1. That's why it's called a well-chosen 1. And we're going to multiply across. So 3 times root 2 is going to be, we learned this last time, 3 root 2. And then root 2 times root 2 is actually root 4, because both of them are under the radical. And the last step is going to be to simplify again. Okay? Because we've already tried to simplify once, and we may have in some problems, not this one, but we're going to simplify again. Okay? What should happen on every one of these is that the denominator should not be a radical anymore. The square root of 4 is really 2. So now our denominator has changed from, it started as root 2, it's changed to a 2. And then on top we have 3 root 2. And that's the answer to the problem. Okay? It fixed the rule. It's not a problem anymore because now we no longer have a square root in the denominator. We've multiplied by something and we've moved it to the top. Now something that you need to remember is that you might have to reduce a fraction. And we'll see if that comes up on another example here. Okay? We got 2 more of this type, ones with square roots in the denominator, so we're going to go ahead and solve those. Our next example, I guess, is the square root of 6 over the square root of 2. First thing we need to do is see if we can simplify any radicals there. Well, square root of 6 isn't going to break down. Square root of 2 isn't going to break down, so no, we can't simplify anything. So now we choose a well-chosen 1, something that we're going to multiply by. And again, we get that from looking at the denominator. Whatever the radical in the denominator is, just the radical part, that's what we're going to multiply by. Okay, so root 2 over root 2. We're going to multiply across. Both of these on top in the numerators are under the radical, so it's the square root of 6 times the square root of 2. 6 times 2 is really 12. In the denominator, we've got 2 times 2, which is really 4. Next step is to see if we can simplify again. Well, 12 breaks down into 4 and 3. 4 is a perfect square, so that means 2, because 2 is the square root of 4, comes out in front, and 3 stays underneath. The denominator should always cancel. The radical should cancel. Square root of 4 is 2. So that's what we've got now. That's simplified. Notice we have no more radical in the denominator, so that's good. That's what we want. But I told you up here that you might have to reduce a fraction. Notice that there's a 2 out in front in the numerator and a 2 in the denominator. Those will cancel. Okay? So we're really only left with the square root of 3, and that's the answer to the problem, is the square root of 3. That's a good example of where we can reduce the fraction at the very end, so make sure you check for that. One more example of this type, we've got 3 root 2 over root 5. We're going to check and see if we can break those radicals down. Root 2 doesn't break down, neither does root 5. They're both prime. So we're going to choose our well-chosen 1. Again, we look at the denominator. We're going to multiply by that over itself. So root 5 over root 5. And we multiply across. Well, 3 is out in front, and there's really a 1 out in front here. 3 times 1 is 3, and then 2 times 5 is 10. So here we do have a number out in front to begin with, though it stays out in front. In the denominator, we've got root 5 times root 5, which is really square root of 25. Now we're going to see if we can reduce. On top, 10's not going to break down. We broke that down in our last video. That's one that you might remember from last time. It's pretty common. It's 5 and 2. Neither one of those is a perfect square, so it stays 3 square roots of 10. The denominator, though, should always simplify. Square root of 25 is 5. And then we need to check and see if our numbers out in front, the 3 and the 5, will reduce. Well, 3 doesn't go evenly into 5. Nope, they won't, so there's our answer. Now, something to be careful about is don't reduce the 5 into the 10, because the 10 is under the radical and the 5 is not. Okay, the 5's out in front, so those don't reduce. Just check the numbers out in front. All right, let's move on to type 2. Type 2 builds on type 1. We only have one extra step, and it's at the very beginning. Okay? We've got the square root, type 2 again, is the fraction under a radical. Here's our example. We have the square root of 2/3. Okay? First thing you want to check for is to see if you can reduce the fraction. Here, 2/3 is not going to reduce. Okay? Always check for that first, because it will make your number smaller on a lot of these problems if you do. But again, 2/3 isn't going to reduce. So our next step is to split it up. And we're going to make it the square root of 2 over the square root of 3. Alright, we take the root of the top and the root of the bottom just to get rid of the fraction under the radical. Now it looks like problems that we did for type 1. Okay, there's a root in the bottom when we need to get rid of that. So we follow the same steps we did for type 1 at the top. We try to simplify the radicals. We can't break down root 2. We can't break down root 3. So we're going to multiply by our well-chosen 1. Again, we look at the denominator, root 3 and root 3. We multiply across. Root 2 times root 3 is really root 6 over root 3 times root 3 is root 9. Now we check and see if we can simplify. 6 is not going to break down. It breaks down into 2 and 3. Doesn't work. Square root of 9, though, is really 3. So here is our answer to the problem. Square root of 6 over 3. Okay? Everything's the same on this one, except for the fact that you have to reduce the fraction first and then split it up. But then it follows the same rules as the other type, as a square root under the square root in the denominator. Let's go on to our 2 more examples, and then we'll be done. Okay? So we have 2 more examples here. The first one is the square root of 6 over 10. Now your first step, this is how it's different, is to check and see if you can reduce that fraction. 6 over 10 is going to reduce. 2 goes into both of those, and 2 goes into 6 3 times, and 2 goes into 10 5 times. So it's going to become the square root of 3/5. Now we split it up, square root of 3 over the square root of 5. That's the other step that's different. And now we follow the same steps as before. We try to reduce the square root of 3, doesn't break down. Reduce the square root of 5, doesn't break down because they're both prime. So we pick our well-chosen one, and again we look at the denominator for that. Square root of 5 over the square root of 5. Multiply across. 3 times 5 is 15, so we have square root of 15 on top. On the bottom, in the denominator, we have 5 times 5, which is really the square root of 25. Square root of 25, the denominator should always break down, and it becomes 5. Square root of 15 isn't going to break down. 3 and 5 are the two numbers that go into it, and they're both prime, so there's no perfect squares that go into it. And then there's our answer, square root of 15 over 5. Again, this is a common example that people will try to reduce the 5 into the 15, but you cannot do that because the 15 is under a radical, the 5 is not. One more example here, the square root of 2/9. First thing we do is check and see if we can reduce that fraction. 2/9 is not going to reduce. Okay, so we split it up, square root of 2 over the square root of 9. Now we check and see if we can reduce them. 2 is not going to break down, but the square root of 9 is. This is a good example of why checking to simplify is always better, because it's going to save us a bunch of steps here, because the square root of 9 is going to reduce. So we have the square root of 2 over square root of 9 is really 3. Then we're done. Okay, we have no more radical in the denominator. It canceled itself out because we checked to simplify here. And we want to do that. Every other step should be to simplify. See if you can simplify. Okay? With the exception of choosing your well-chosen one and multiplying. Those are the only two that are different, where the next step isn't to simplify. But you should always be checking to simplify, because it will save you a lot of work. Okay? Again, that one we don't have to go through all the steps because we checked here and we got the square root of 9. Square root of 9 is 3. No more radical in the denominator. Okay? Well, those are your examples in your notes on rationalizing the denominator. Make sure you understand the differences between the two types of problems. The first one, where you have a radical in the denominator, how to get rid of it. And the second one, where you have a fraction under the radical, how to get rid of that. Okay? Make sure you understand all that. Bring your questions to class tomorrow.